In this video, we'll take a look at solving exponential and logarithmic equations. And to do so, sometimes we have to use the other form. So to solve an exponential equation, if the unknown is in the exponent, we have to convert it to log form. To solve a logarithmic equation, if the unknown is the argument or the base, sometimes we have to switch it back to exponential form. So we use a lot of switching back and forth in order to solve these kinds of equations, and that's why initially when I introduced logs to you, I said it's very important to be able to switch forms. Any of these three variables can be the unknown, x, y, or b. So I've written out some guidelines for solving exponential and logarithmic equations. Basically, use the two forms together, switching when it is helpful. If the equation is in exponential form and x is the unknown, change to logarithmic form and solve for x. If the equation is in exponential form and b is the unknown, take the log of both sides and solve. In doing this, you might need to change a log form back to exponential form. If the equation is in logarithmic form and y is the unknown, change to exponential form. Note, before changing to from log form, the coefficient of the log must be 1. We will look at an example of this and how to do it. If the equation is in logarithmic form and b is the unknown, change to exponential form and take the log of both sides. You may need to convert back to exponential form again. So now I have some examples for each of these four types of solving these equations. So let's take a look. And remember, trial and error is not permitted, she says with a smile. So really try to resist doing that and use the properties of logs and use the other form to solve logarithms. So notice what we have. We have an unknown in the exponent. What we have is an exponential form. We have a base raised to an unknown value equaling a number. This is the exponential form. So we have an equation in exponential form where the unknown is in the exponent. That's number one. The equation is in exponential form and the unknown x is in the exponent. We need to change to logarithmic form and solve for x. So last week you learned about changing to logarithmic form. So let's do that. X is equal to log base 3 of 18.381. Now in the previous video, you looked at solving this type of a logarithm by writing the log of the argument, log of 18.381, and dividing by the log of the base. And we've just put that in the calculator exactly as we see it. Log 18.381 divided by log 3. And the answer is 2.64995. Let's just say 2.650. We'll go 3 decimal places for our practice here. In the next one, we have the unknown as the base, b. b is raised to the power 4 and it equals this number. Well, when it's a 4 or an integer like that, sometimes it's easier to just take the 4th root then of both sides. But this could be an integer or a decimal value, and then it would be a little more confusing taking a root of a decimal value. So another way to go about it is take the log of both sides. That just means log both sides. So log of 1296. Now this is a log base 10 because I haven't written any base. And I'll do log base b of 4. And here's where it's important to remember that power rule for logarithms. What else can I do with this 4 right here? Well, remember that 4 can also be placed here. So let's do that. We've got log of 1296 equals 4 times the log of b. Okay, before we can switch back to exponential form, we must have a coefficient of 1 in front of the log. And right now it's a 4, so we must divide both sides by 4. Log, and that doesn't mean divide 1296 by 4. We divide log 1296 by 4. So keep writing it like that. And that is equal to log b. Now that we have coefficient 1 in front of the log, and there's nothing more we can do to isolate b, we must go to exponential form. All right, when it's exponential form, we need to say the base. What's the base? Well, there's nothing written here, so it's a 10. So it's 10, and what is the exponent? Well, this side has the log expression, so this equals the exponent, so does all of this. So 10 to the power of log base, the log of 1296, divided by 4, equals b. And this is something you're just going to put in your calculator. Let me do that a little bit neater. The log of 1296 over 4. So I suggest using the fraction key for this. We're going to raise 10 to the power, and that's the anti-logarithm. So the second function of the log key. So second function log. Now I want to fill in that exponent, but it's a fraction. So I'll use my fraction key. In the numerator, log 1296. In the denominator, 4. Equals, and you should be getting 6. B equals 6. Now that's confusing because of the way the letter came out. That's a B. This is the number 6. All right. So that just means that 6 to the power of 4 equals 1296. And we could double check that. 6 to the power of 4, 1296. Log both sides, divide by any power, and then change back to exponential form. Now let's take a look at this example. The unknown is the argument y, and we know that if we change from this log form to exponential form, it will solve for y, because 3 to the power of 5 equals y. These are the easiest ones, and they don't appear to be right off the bat. So I'm just going to switch that order around. Y equals 3 to the 5. Y equals, use my calculator with my exponent key, 3 to the power of 5 is 243. Now I could switch to exponential form because I had coefficient 1 in front of that log. Over here we don't. So let's make sure that before we switch to exponential form, we divide out any coefficients, all right? So we'll divide this side by 2, we'll divide this side by 2, which leaves us with 5 equals log base 3 of y, and in fact, then it would continue from there exactly like the other side. Y equals 3 to the 5, y equals 243. All right, so you must have coefficient 1 before you change to exponential form. In this last one here, we'd like to take a look at solving for base b. So let's see. What does it say in our instructions here? If the equation is in logarithmic form and b is the unknown, change to exponential form and take the log of both sides. You may need to convert back to exponential form after we take the log of both sides. So we're going to exponential form twice in a way. So let's see. We need to go to exponential form. B to the power 3 equals 64. Some base raised to the power 3 equals 64. Some of these you know in your head, but you need to know the process. So let's take the log of both sides. Log of b to the 3 equals the log of 64. It's an equation. We're just doing the same thing to both sides. So now this 3, I need to get it out of there. It needs to come this way. 3 log b equals log 64. Now we can divide the 3 because we cannot change to exponential form until we have a coefficient of 1. So I'm going to put this in here. We're going to divide both sides by 3. And I get that log b equals log 64 divided by 3. And now I can go to exponential form because my coefficient here is 1. So the base is 10. The exponent is everything on this side. Log 64 over 3 equals b. Using your calculator, raise 10 to this power. 10, or second function log. And then I suggest the exponent key or brackets around it, okay? Because you have to raise it to this whole power. Log 64 divided by, or fraction to the denominator, 3. And that answer is 4. 10 to the log 64 over 3 equals 4. Let's try this one. It's much less obvious. Changing to exponential form, b to the 3.5 equals 529. Take the log of both sides. The log of b to the 3.5 equals the log of 529. Move this 3.5 in front. 3.5 times log b equals log 529. Divide both sides by 3.5 to get coefficient 1. So we get log b equals log 529 over 3.5. Now that it's coefficient 1, we can change back to exponential form. What's the base? Everything on the other side is the exponent on 10. 10 to the log 529 over 3.5 equals b. Make sure you can find this value on your calculator. Use the second function of your log key. It's the 10 to the power. And use a fraction key or use brackets around the division. All right, I'm using the fraction key. I do log 529 and move down to the denominator. 3.5 is the divisor. Equals, we should get b equals 5.9997. It'd be essentially 6, right? Okay. Here's an interesting application of logarithms involving the pH of water. Hydrogen ion, or H+, okay, is the hydrogen ion concentration in water. It is an indication of the acidity or the alkalinity of water. Neutral water has a pH of 7. So anyone with pools or hot tubs has experienced this terminology before. And if not, well, something new that you are experiencing. So the equation for pH is the negative log. Notice the negative. I want to really make that bold. The negative log of the hydrogen ion concentration. Find the hydrogen ion concentration if the pH of water is 5.6. So if we sub in a 5.6 for pH, And we say that that is equal to the negative log of hydrogen ion concentration. Here we don't have coefficient 1, we have coefficient -1. So we should divide out by -1 or multiply by -1. Either way, it's going to change this negative sign from this side over to this side, right? So -5.6 equals the log of the hydrogen ion concentration. Now we have coefficient 1. So we can change to exponential form. What's the base? It's not stated, so it's a 10. The exponent is -5.6. 10 to the -5.6 equals the hydrogen ion concentration. And using your calculator, you can find the anti-logarithm of -5.6. Second function log, minus, don't use your subtraction key, use your negative key, 5.6 equals. And you should see on your calculator the hydrogen ion concentration is equal to 0.000002511. This is the kind of number that is, it's useful to use scientific notation. And so this will be equal to 2.511 times 10 to the power of 1, 2, 3, 4, 5, 6, -6 moles per liter. All right, going in the other direction. If the hydrogen ion concentration of a sample of water is 0.000000006 moles per liter, find the pH. So pH is equal to negative log of the hydrogen ion concentration. I better write down the right number of zeros. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Punch that into the calculator. Use the negative button. Touch the log. 0.000000006. And this is a pH of 8.2. Here are some more examples that we can go through. I'll show these two on the screen. If you want to pause the video and give these a try, and then I'm going to take these two up. Then I'll show the other ones, and you can try them again as well. The x is in the exponent. In this exponential function, we should write it in logarithmic form. Once it's in logarithmic form, we can find this log base 3 by making it a ratio of the log of the argument over the log of the base. And you can use fractions with your log button. So use your fraction key. Log, fraction, 1/81. Move the arrow over to punch and divide, log 3. The answer is -4. E to the -3x equals 100. This is exponential form as well, with the unknown in the exponent. So we should say that the exponent -3x equals log base e, right? Log base e of 100. Now, from our studies of natural logarithms, you found that we don't write log base e, so this really should be written like this. Ln 100, which is a value you get directly from your calculator, equals -3x. So x is equal to ln 100 divided by -3. And that number is ln 100 divided by minus 3, minus 1.535. Now there are two more for you. Pause the video and try to solve these two. This one is in exponential form with the unknown in the exponent. I'm going to switch to log form. So x plus 3 is equal to log base 6 of 0.005. Well, log base 6, I wrote that a little bit high, just a second there, 0.005. This is just a number I can get from my calculator. So I think we will do that. And then we will be subtracting 3 from it when we move the 3 over, won't we? So x is equal to log base 6 of 0.005. That's a number. Subtract 3 from it. All right. Log of 0.005 divided by log 6. Hit the equals, then subtract 3 from it. And you should get log 0.005 divided by log 6. Hit equals now. You should see minus 2.957. Now subtract 3 from that. Minus 5.957. Here we have the unknown in the argument. Now, in exponential form, it's solved for the argument. So we should change to exponential form. But we can't do that until we have coefficient 1. So we must divide this 6 from both sides, okay? So 6 log base 30 of x equals minus 3. We'll divide that by 6 there. We'll divide this by 6 here. That will give me log base 30 of x equals minus 1/2. Now I have coefficient 1. I can change to exponential form. And I will say then 30 to the minus 1/2 is equal to x. Using the calculator in this exponential form, we evaluate this exponent 30 to the power of minus 0.5 or minus 1/2. And in decimal form, x is equal to 0.18. I'll stop at 3 decimal places, 183. It says 0.182574185. I'll write it all down in case you're checking your calculator. All right, one last one here. We are solving for this x way in here. It's in the argument. So as you can see, we should isolate this whole term first. Then we will be able to switch to exponential form to solve for the argument. So this is a plus. Let's take this one, which as you can see is just a number that you can get from your calculator. We'll take this and we're going to put it over here. It's going to have to be subtracted from the other side, leaving minus log base 2 of x equal to log base 2 of 45, subtract 2 log base 2 of 3. Now there are two different ways we can go with this. we could just, right now, I want to make this a positive, so I can switch the sign of everything. That means this one's going to go positive, this one will go negative, this one will go positive. How about that? It's just multiplying through everything by -1. So I like that because that's going to set up my positive right there. So I'll write this as a log base 2 of x equals, and I'm going to put the positive one first, 2 log base 2 of 3, subtract log base 2 of 45. These are numbers we could just get on the calculator. But we can also practice those properties of logs. Since we have a difference of 2 logs with the same base, we can combine them, but only when the coefficient is a 1. So this 2 is going back up here. So log base 2 of x equals log base 2 of 3 squared, subtract log base 2 of 45. Log base 2 of x equals, now these are both coefficient 1, right? With a subtraction between, combine them. What does you do with the two arguments? Since it's a subtraction, you divide, right? So log base 2 of 3 squared over 45. So log base 2 of x equals log base 2 of 1/5. Just reduce the 9 over 45. And now we have two things that are arguments that are both log base 2. So if that's the case, then x must be equal to 1/5. That is my examples for solving exponential and logarithmic equations.